last experiment that you're going to do as part of the basics of making class is to do some concentration monitoring using a RodeoStat Potentiostat. And the first thing that you've got to do is make sure that Python is working. Once you've loaded Python, make sure you check to see that the top line says Python 2.7.x, etc. If it says Python 3.x, you're not going to get this to work because the RodeoStat software does not work with Python 3. Then you're going to need to check the potentiostat. Make sure that you go through the device manager and find the correct COM port for it. Make sure you write that down because you're going to need to have that later. Then you're going to open the experiment using the Rodeo Plus -py27.py file. It's in its own folder and it should be on the desktop of your computer. And then I want you to run the module. You should pull up a multi-channel cyclic voltammetry measurement and don't hit run until you're absolutely ready to run the experiments. The problem is that if you try to run it and then you try to rerun it, you're going to have a conflict between two different runs of the same, what you think is the same experiment. Windows won't know what to do. So when you do the experiment, you're going to need to place the electrode sensors into the solutions, note which ones have which concentrations, and then attach all sensors to the potentiostat. As this is a multi-channel potentiostat, you're going to be doing multiple experiments at once for several concentrations, and you're going to need to know which channel is associated with which concentration. Then you're going to ultimately switch your vials with different concentrations of the analyte to other groups, and you're going to develop an entire calibration curve during class. Okay, make sure that you track which COM port you've got on there and click Run Once Only. The Python shell will tell you that when your reading is complete, it should take several minutes, and the output is going to be a .txt file that you're going to need to import as an Excel sheet. To analyze the data, you're going to analyze it in Excel after the fact. Ultimately, you're going to graph voltage versus current for each of the concentrations, and the resulting data is going to be a set of cyclic voltammograms. You're going to need to ultimately curve fit the concentration versus current points from each known concentration solution, and then identify the concentration of an unknown solution. When you are done, the solutions are reusable. Remove the sensors and put them away. Don't wipe your electrodes, as that'll wipe away the graphite. Spot dab them instead, and that'll soak up the solution. The potentiostat is one unit, and it has 7 channel attachment that you can plug into it, as well as the wires. The results that we got for ascorbic acid, vitamin C, for the current versus voltage plots are shown on this slide, where the concentrations in millimoles per meter of the vitamin C are in the legend. It would be desirable to get a nice linear calibration curve between current and concentration. That's not what you get here, but it is a smooth monotonic function that you can use taking current and from your potentiostat experiment and estimate the concentration for the vitamin C for any unknown.